Welcome to this installment of Math Dive in 5. We're here for Unit 8 in Grade 5, Problem Solving with the 4 Operations. This video will focus on the last section of this unit, which is area and perimeter of rectangles with decimal side lengths. On the next slide, you're going to see a task. We'd like you to pause the video on that slide, complete the task by yourself or with your team or a partner. While you're working, consider the misconceptions and struggles that might occur with the students in your classroom, and think about strategies that could be used to find the area and the perimeter of rectangles with decimal side lengths. We'll see you back in a few minutes. We will come back to that task in just a moment. For right now, we're going to look at the best standard progression. Looking at second grade, you can see that they are finding perimeter now in second grade of rectangles. They'll be using unit segments to count the perimeter. They're also going to find perimeter of polygons with whole number side lengths.
So taking that information as a second grader, when I step into a third grade classroom, I'm going to now add on the idea of exploring area by covering the shape with unit squares, and then find the area of a rectangle with whole number side lengths. So I see two big things there: exploring it, making sense of it, and then somehow determining with some strategy what the area of a rectangle is.
Correct. And they're also going to be bringing in some of the perimeter from second grade when they solve some word problems about area and perimeter of rectangles.
Yeah, and then of course in third they're going to apply it.
Right. In fourth grade, they are going to continue with perimeter and area. We're also going to start looking at unknown side lengths. So when I know the perimeter, for example, but I might not know one of the side lengths of that rectangle, they'll be having to figure that out. And solving problems with rectangles that have the same perimeter and different areas, or the same area and different perimeters.
So if I'm thinking about area, I just had a connection here. If there's a missing side length, if I'm thinking about area, like length or width, I'm thinking, oh, that connects to division.
It does.
And then I can see how multiplication and division are inverse operations within that benchmark.
Exactly.
And then in grade 5, we're still finding the perimeter and area of rectangles, but you got to read carefully here. It's with fractions or decimal side lengths. So they're applying what they know about decimals and strategies for adding decimals or subtracting, and applying it to this measurement strand, also that benchmark. Yeah. So
and multiplication and division are going to come into play
with the area. Yeah. Yep. It's all there.
So now going back to our original task from today, Margie is finding the area in order to determine how much carpet to buy.
Right.
So with this task, I would recommend maybe giving them a cutout rectangle that is in the dimensions of base 10 blocks. So if I want the base 10 blocks to represent the feet, I am going to use a rectangle of construction paper that is 36 centimeters by 74 centimeters. And then students should be able to cover it with base 10 blocks to solve. So first I'm going to start by putting whole units, right, whole squares.
There's my flats, which if we're saying that is worth one whole.
And each of those flats is 10 centimeters by 10 centimeters, so that is going to cover up
10 times 10 is 100 square centimeters.
Yes. But 1 square foot, because that square is representing one square foot, right?
That makes sense.
That flat from the base 10 blocks is representing 1 square foot in this model. Now I have to switch gears to my tenths. And my tenths, if you measure those longs of the base 10 blocks, they measure 10 centimeters by 1 centimeter, and I'm going to start covering up as much as I can of this model with those tenths.
So that's some problem solving there. I might not say, okay, if you figured out that the flats cover that much, then you got to problem solve and figure out, well, I can't use flats anymore.
Right.
What tools do I have available to me?
So now no more flats and no more rods will fit. So now which tool do I need to go to?
Well, I have those small cubes.
And Daryl, what do those small cubes represent?
Well, if the flat is 1 hole, the rod is 1/10, the cube's going to be 1/100th.
Exactly. So I'm going to cover up that remaining space with my hundredths.
Okay.
Okay.
I see that.
All right. So now I can make my connections to the open area model, right? I have 3 holes and 6/10 that I am multiplying by 7 holes and 4/10.
I see that on the dimensions. I can see the 3 holes over here where it says 3.6 feet. There it is, 3 holes, 6/10. I see the same on the 7 holes and 4/10.
All right,
Got
so
that.
we're going to take a look at all of the holes that we were able to put into that model. And we are representing the product of 3 holes by 7 holes, right?
Basic fact.
And when I count all of those square units, I find 21 of them. 3 rows of 7 is 21.
Mm-hmm.
Then we're going to take a look at this bottom section where we added tenths at the bottom of our model. And that has the 6/10 from 3 and 6/10 feet multiplied by 7 holes from the 7 holes and 4/10 side.
And if I need help with that, I could still think about that and go back to 3rd grade and think about groups of.
Exactly.
7 groups of 6/10, right?
Exactly. So I am multiplying 7 groups of 6/10. I'm going to get my product and I'm going to fill that into that rectangle. Then I'm going to look at the other tenths that we added to the model, and this represents the product of 3 holes. I have 3 rows of 4/10, and when I calculate that, I get 1 and 2/10.
Mm-hmm.
What's remaining are my tenths times tenths, and tenths times tenths, Daryl, is going to give me?
Well, if I think back to what I've already learned, I know when in my patterning, I'm looking at the anchor chart here, when I multiply tenths times tenths, I get hundredths.
Exactly. So my product should be in the hundredths place, right?
Sure, and I'm just going to think of a basic fact. 6 times 4 is 24, which is a strategy.
Exactly.
And sense making tells me that I'm taking part of a part, so it's got to be 24 hundredths.
It is 24 hundredths, and we're going to go ahead and fill that into our open area model. We know that we can also take the base 10 blocks and we can exchange 10 tenths for a whole, 10 more tenths for a whole, 10 more tenths for a whole, 10 more tenths for a whole, and 10 more tenths for a whole. I don't have enough to exchange for any more wholes, so now I'm going to switch to those hundredths. And Daryl, how many, or what am I going to exchange 10 hundredths for?
Well, I can exchange 10 hundredths for 1/10.
Okay, so I'm going to take 10 hundredths and exchange it for a tenth, and 10 more hundredths and exchange it for another tenth. I can do no more exchanging. Daryl, how many total holes do I have?
So you had 21.
Mm-hmm.
I see 4 plus 1 more, so that I have 26 holes.
And how many tenths?
I see 6 tenths, and I see 4 hundredths.
So my product is going to be the same as it would be if I add up all of those partial products that are inside my open area model.
And you've lined up your place values.
I have, and my product is 26 and 64 hundredths, which is the same product you got when we counted up our base 10 blocks after regrouping.
So the area of that room, I need 26 and 64 hundredths of carpet.
Hundredths what? What's my unit?
Oh, feet squared.
Square feet.
Yes, because otherwise,
yes.
That's right. I need to make sure I put the units with the numbers. Otherwise,
Exactly.
It's not part of the context.
We know how much carpet she needs. Now we need to figure out how much border she needs to put up at the top of the walls. So the first thing I need to know are what are those two missing side lengths? And by 5th grade, students should know that opposite sides are congruent, right? So we know that the opposite side is also 3 6/10 feet, and the opposite of the 7 4/10 is also going to be 7 4/10 feet. One way to solve for perimeter is to add up all of those side lengths. So I can just take each of the side length measurements going around the perimeter of that rectangle, add them all together, and I get 22 feet of border is what I would need. What's the other way to do it, Daryl?
Well, I could, I see some multiplication here. I can multiply 3.6 times 2.
Because I have two of them.
Two of them, and I can have two 7.4, so I can multiply those by 2, add those products, and that would give me the total perimeter.
Exactly, and the total perimeter is still 22 feet. So real quickly, just pointing out a few things from the item specifications. This benchmark could be assessed with context or without context. Now our Margie problem had context, but they might just be given a picture of a rectangle and be asked to find the area and or perimeter.
Also, the idea that the side lengths, I think this is really important, are either going to be all decimal lengths or written in fraction form. It will not be mixed.
They're not going to mix decimals and fractions. And one more thing about the assessment limits, students aren't going to be using that exponent 2 to represent squared. It will be written out as square feet, square centimeters. We're going to use the words and not the exponent.
One thing to notice on these ALDs, or achievement level descriptors, is that in finding perimeter and area, there's no mention of the word rectilinear. So that would, if you do come across a problem with that, that would be an extension to this benchmark.
Correct. And in the past, we've seen rectilinear figures in both 3rd and 4th grade, but it is not listed anywhere with this benchmark in 5th grade. So just a quick recap, we can use the base 10 models to represent the area and or the perimeter of our rectangles. And we can make connections between that rectangle and the open area model, which is our representational thinking. And eventually we're going to get to the abstract thinking where we're just going to be multiplying the two side lengths together because we know that length times width is equal to the area.
Exactly.
Thank you for joining us for this edition of Math Dive in About 5. We'll see you back next time for another Dive in 5.
Bye.
Bye.